Okay, so this mini lecture is going to look at energy. And what is energy? And what in energy are we going to focus on? And what are we going to do with it? So energy, fundamentally, is the ability for an object to do work. We've already talked about work. And in order to do that work, an object has to have energy. And once an object has energy, it then has the ability to do work. It's sort of circular. And in fact, these two are very intimately related. If I do work on the object, I change its energy state. If I change the energy state of an object, I have done work. So energy fundamentally is the ability for an object to do work. That means we need to be able to apply a force through a distance. That's what our work relationship is. So we're going to look at two types of energy that enable us to apply a force through a distance. Those two types, and there's more than just our two types of energy, but we're going to look at a subset of energy called mechanical energy. And only two types of mechanical energy that we are going to look at in this last little bit of time we have together is what we call potential energy or gravitational potential energy and kinetic energy. So, what are these two types of energy and kinetic energy? We'll look at one at a time. First, let's talk a little bit about, oops, I forgot an L in there, gravitational potential energy. If I do work on an object, we said we give it energy. So let's look at an example of me doing work on this eraser. So the eraser is sitting here at this level, and I'm going to apply a force and move it through a distance. I've just done work, so did gravity. It did negative work, and I did positive work. I just applied some work on this object, and now it, by definition, has to have some energy. Well, does it have energy? How would I know if it had energy? Well, if it had energy, it would have the ability to do work, which means this object should be able to do work on another object. If I had a pile of bowling pins here in front, and I let go of this object, would it be able to do work on those bowling pins? Yeah, it'd be able to knock them over to move them through a distance. So there must have been some energy involved. Gravitational potential energy is the energy of position. Every potential energy is a type of energy due solely because of the position of an object. Whether that position is what we're going to look at in terms of height with gravitational potential energy, or a spring and that we squish together, we've changed the position of the spring itself, we've compressed it, it has the energy then to do work. Or if we pull two electrons, or an electron and two electrons, if we pull two electrical materials apart, now we've changed their position relative to one another, and they have the ability now to do work. So energy. So all potential energy is the energy of position, a positional related potential energy. Gravitational potential energy is the energy of a position due to an object's height above a reference point. So here's another case where we need to define a reference point. Just like in motion, when we defined an origin, for potential energy, we need to be able to define that reference point. So let's think about what might influence potential energy. We will call this reference point H equal to 0. We're going to use H. It's common to use H in gravitational potential energy, so that's going to be our height. It's all related to height, so we'll call that height H. The first thing we have to define is that height equal to 0. So where our reference point is, which is height equal to 0. All right, so what might influence the potential energy of an object? Let's imagine if I raise this eraser up, it could do some damage if I let go of it. If I raise it a little bit higher, it could do some more damage if I let go of it. So the height itself above 0, we'll call that the height. If I increase the height, I'm going to increase the gravitational potential energy. You see gravitational potential energy often written as GPE, gravitational potential energy. You might also see it written as U. And then there might be a subscript there for gravitational potential energy. U sort of represents all potential energy. When you're dealing only with mechanical energy, we do tend to get a little lazy and we might just put in a U, or we might just call it potential energy. So depending on what you're looking at, if you're talking about gravitational potential energy, these abbreviations might show up. So if I increase the height, I increase the potential energy. What else might increase my ability to do more work? Well, I could use this eraser, or I could use my computer. Which one's going to do more damage? Well, this has a lot more mass than the eraser. It's going to do more damage, not only to whatever it's hitting, but of course to the computer too. So if we increase the mass of an object, then we increase the gravitational potential energy. So both of those things play an important role, and part of the reason the mass plays that important role is because of the weight of the object. And the other thing that's related to gravitational potential energy is our gravitational constant G. So if I were to go to the moon, the amount of potential energy I have is actually less, because the gravity is less at the moon. When we put all these pieces together, we find that the gravitational potential energy is equal to the mass times the gravity times our change in height. And this is our change in potential energy, which is typically what's important for us. But we tend to also, in a lot of, if we're clever about our analysis, we set that initial height to be 0. And it's really the change in energy that allows us to do work. And so we'll often see the gravitational potential energy as just mgh. Okay, so at any given height, but that h is relative to 0. All right, or the change where we have an h relative to whatever we start an initial and a final. Okay, what about the other type of energy, kinetic energy? Well, we've learned that word kinetic before. It dealt with it in kinematics, and we dealt with it in kinetic friction. This has to do with moving. So imagine you are, and this is very intuitive energy. Imagine you're in your bedroom and your snotty little younger brother is holding the door shut. You want to get in that door. Well, you might push it. You're trying to do work on the door. You're trying to move that door through a distance, get it to open up. You might push it a little bit, and that doesn't work. So what do? You take a running start and you jam your shoulder into it. Or what did the princesses do when they were saving the prince from the castle and the dragon? Well, the princess got a battering ram, and she rammed that battering ram into the door to save the prince from the dragon. So you get moving, and kinetic energy is related to motion. If I increase my motion, my speed, I can increase my kinetic energy. Also, what else did the princess do? She got a battering ram. She increased her mass. What do you do if you can't get your little brother to open that bedroom door? You go get Dad. Oh, or your larger grandpa, or a horse. Whatever you go get to ram into that door. You increase, if you have a horse, not sure where that came from, you increase the mass. That will also increase the kinetic energy. Now it turns out in kinetic energy, one of these is a lot more effective than the other. The relationship for kinetic energy is equal to 1/2, this is an empirical constant, it was just determined based on experimentation, 1/2 the mass times the speed squared. So even tiny little changes in speed have big changes in kinetic energy. That's what you try first, right? Try to ram your shoulder into the door before you go and get something that's more massive like a battering ram. All right, so that's our relationship for kinetic energy. So we're going to look at 2 types of energy. We're going to look at gravitational potential energy. Things with more potential energy are raised to higher heights or have more masses. And we're we're going to look at kinetic energy. Now, specifically, we're going to look at how these two things work together to give us information about how a system is moving or has done work or has changed its state. So we're going to look at that next. Good job.